Okay, video notes on rotations. So we know previously that we've worked on transforming a shape or a figure on a coordinate plane by using a translation or a slide. Now we're going to do the same thing with a rotation, which means turn. So your objective is to rotate a pointer figure on a coordinate plane by writing notes, watching the video note taker, and practicing for mastery. Okay, then to rotate a pointer figure and tell the new coordinates by writing notes, watching the video note taker, and practicing for mastery. So we have our vocabulary. So we know that transformations from previous notes are rotations, reflections, and translations. Okay, we already know that a translation is a slide. We already know that from previous work. So now we have rotation, which is a turn. So you have 3 degrees of turn, 90 degrees, 180 degrees, and 270 degrees. Those degrees come from a circle, which is 360 complete degrees. We know an ordered pair, okay, has coordinates, in this case 3 and -4. And we know that each coordinate is x and y. Sometimes kids are getting those mixed up. The ordered pair is both coordinates together. Okay. So, rotating a point on a coordinate plane. So, just like we did before, we have steps. So, you find the coordinates of the point. Okay, right there. -5, 3. Simple. Now, you're going to determine which direction, clockwise or counterclockwise, that a rotation goes. Okay, so that's right here. They're going to tell us we're going to rotate the point 90 degrees clockwise. We know clockwise is to the right, counterclockwise is to the left. So 90 degrees is 1 quadrant. 180 degrees would be 2 quadrants. 270 degrees would be 3 quadrants, and obviously a full circle would be 4 quadrants, which would kind of be useless to do. So determine the degrees of rotation. Is it 90, 180, or 270? In this case, it's 90. So that's going to be 1 turn to the right because we know it's clockwise. Now, determine which quadrant that point will be rotated to by using the direction and the degrees. This will tell you the sign of the coordinates. So I'm going to this quadrant because it was 90 degrees to the right. We know then that our our coordinates have to be positive, positive. So now the rule for rotation is every 90 degrees I flip the x and y coordinates. The sign is based on what quadrant they're in. So I have to know my quadrant. So in this case, I'm going from here to here, 90 degrees, which means the 5 and the 3 get flipped, 3 and 5, and they become positive because I'm in quadrant 1. Okay, fairly simple. So now we'll use that rule down here. All right, so first thing is identify those points. Okay? All right, so we know that's over 5 and up 4. Okay, second, determine your degree of rotation. So I'm going 90 degrees counterclockwise. That means I'm going to the left, and 90 degrees is 1 quadrant. So I'm going to go over here. Again, that tells us what the sign is going to be. So in this quadrant 2, our sign has to be negative, positive. Okay, if my original ordered pair is 5, 4, we know that every 90 degrees we rotate, we flip these, or switch them, I think is a better word. So then over here, this would become 4, 5. But we know in this quadrant that it's got to be a -4 and then a +5. So now we can plot them. -4 and +5. Now, what happens in a rotation is this distance right here from the center or origin there is going to be exactly the same distance here. So look what happens if I continue my rotation. So I'm going to continue going around. So now it's going to go back to 5, 4. But in this quadrant, they both have to be negative, don't they? So that's going to be a -5 and a -4. So -5, -4. Okay, so again, if I draw, and then finally to this last one, if I continue that rotation, I'm going to get from 5 to 4 to 4 to 5. But in this quadrant number 4, it's positive and then negative. So that's going to be a positive 4 and a negative 5. So positive 4 and negative 5. And you can see that we made what? We made it kind of an X. And then each one of these would be the same distance from the origin. Okay, next one. So if I have a point here and it's positive 1, negative 5. Okay, I'm going to write it down here. And I go 180 degrees clockwise. So that means I'm going to go this direction. So there's 90 degrees to that quadrant, and then 180 degrees to that quadrant. So 90 degrees here would take this 1, negative 5, it would flip it to 5 and 1, but they both have to be negative because they're in the third quadrant. And then I would flip it again back to 1 and 5, but in quadrant 2, the first one's negative. So 1, negative 1, positive 5 would be my new point. All right? Watch what happens when if I draw a line between these. Look, it's just a straight line through the origin. Now, hopefully you can come up with a shortcut. Instead of doing 2 90 degrees, what actually happens when I go from here to here? Analyze those two and see if you can come up with a shortcut. Okay, rotate 270 degrees clockwise. So, here I'm at negative 4, negative 6. So we know that clockwise is this direction. So I'm going 90 degrees once, 90 degrees again, and 90 degrees there. So if I go ahead and change this from negative 4, negative 6, so up here would be 6 and 4, but then this would have to be negative because it's quadrant 2. Okay, another 90 degree turn, I have to switch the x and y, so it would be 4 and 6, and they both stay positive. Then another 90 degree turn would be back to 6 and 4, but this time in quadrant 4, that's negative. Can you see a better way to do that? I do. Instead of going 3 spots around, how about I just go back 1 that direction? So 360 degrees clockwise, if I were to subtract 270, it's the same as going 90 degrees counterclockwise. So I can use the idea of the whole circle to figure out another way to do that. And then if I do one rotation, 90 degrees, means I switch the 4 and the 6 to 6 and 4. And then since we're in quadrant 4, I know it's positive, negative. So over 6, down 4. All right? Not too bad. Okay, rotating a figure on a coordinate plane. So this time you're going to do the same thing for each point on the figure as you did for the point that we had individually on the work we just did. So I have to identify each point here. So that's going to be, what is that? Over negative 2, up 2. Okay, over negative 3, up 7. Over negative 7, up 5. Okay, we're going to go 90 degrees clockwise, so that means we're taking it this direction. So that means I take each of these points, I look at their coordinates, and I switch them. So this is going to become a 7 and a 3, and since I'm in quadrant 1, they remain positive. Okay, this is going to switch to 2 and 2, and they stay, or they become positive. This is going to go 5 to 7, and they become positive. So now I can plot my new points. Over 7, up 3, over 2, up 2, over 5, up 7. And my new shape would look like this. So now it's still congruent, like in translations, but it's turned. Okay? Around this point right there. Okay. Hit. Every point on the new transformation must be the same distance from the origin as the corresponding point on the pre-image. So if I were to say that this is A, that's B, that's C. Okay? Then, this one right here, which is 7, 3, okay? That's your B prime. Okay, this would be your C prime, and that would be your A prime. What I'm saying there is this distance from here to here is the same distance as from here to here. This distance from here to here is the same distance as from here to there. This distance from here to here is the same from here to here. So you can actually look at the two shapes and kind of estimate. All right, this one we're going to rotate the figure 180 degrees counterclockwise. So let's find the point. So that's going to be over 4 down 2, so 4 negative 2. Okay. This is going to be over 6 down 3. This is over 4 down 7. And this is over negative 2 down 4. So there's my 4 sets of ordered pairs. I need to go 180 degrees clockwise. So these 3 points are going to end up over in this quadrant. This one is going to go in this quadrant, 180 degrees, counterclockwise. Get it? Here, here, here. And this one, all right, would go here and then there. So basically you're just going across the origin to the opposite quadrant. So we know from our work then that when we do this, we have to change the coordinates once and change it again. Did you figure out the shortcut? Well, let me give it to you now. If I change once and then change again, that means these sets of coordinates are going to come back to be the same. So 4, 2, they'd be 2, 4 here, back to 4, 2 there, but now they're in quadrant 2, so it's got to be negative 4, positive 2. 6, 3 would be 3, 6 here, and then back to 6, 3 there, but since it's in quadrant 2, it has to be negative 6, 3. This one would be 4, negative 7 would be 7, 4 here, then back to 4, 7 there, but it's in quadrant 2, so it has to be negative 4, 7. This one, okay, is going to be negative 2, 4, so it's going to be 4, 2 here, then it's going to be back to 2, 4 there, but it's in quadrant 1, so it has to be positive. So when you rotate 180 degrees, you keep the numbers x and y in the same position in their ordered pair. You just make sure you put the right sign based on the quadrant. So now if I were to plot them, negative 4, 2, negative 6, 3, negative 4, 7, 2, 4, connect them, and I have the same type of quadrilateral. Okay? If I go ahead and take each of these and turn them, eventually it'll land on that. So let me see if I can show you that. Okay? Okay, and then if I turn it, eventually it's going to be turning around this area right here, and it's going to turn at the same time, all right? And eventually it's going to turn back so that it looks like this one, because remember it's congruent. And there it is. Okay? Or back, around, back that other direction. Okay? I can't really rotate around the origin. So there it is. Right, so what did you learn? Every time you rotate a point 90 degrees, clockwise or counterclockwise, you do what? You, let's say, switch the coordinates and use the sign or signs of the quadrant. Quadrant 1, positive, positive. Quadrant 2, negative, positive. Quadrant 3, negative, negative. Quadrant 4, positive, negative. Every time you rotate a point 180 degrees, you keep the coordinates the same. And use the sign of the quadrants. And if you paid real good attention, you know that when we go 180 degrees, that look what happened. 4, negative 2, negative 4, positive 2. 6, negative 3, negative 6, positive 3. 4, negative 7, negative 4, positive 7. Negative 2, negative 4, positive 2, positive 4. What happened to the sign each time? Yeah, you got it. We kept the numbers the same, but we switched the signs. So 180-degree rotation is easy. What will be the new coordinates of the point 8, negative 2 if you rotate 90 degrees clockwise? So I don't need the coordinate plane to do this. I have a rule. I know that I'm going to switch these around. So instead of 8 and 2, it's going to be 2 and 8. And then the sign is going to be what? Well, if I'm at 8, negative 2, that means I'm going to the right and down. That puts me in quadrant 4. If I rotate 90 degrees clockwise, that means I'm going to be in quadrant, yeah, you got it, quadrant 3. Quadrant 3 has to be negative, negative. Okay, last one. What will be the new coordinates of the point negative 4, 5 if you rotate it 180 degrees? All right, well, we just got done talking about that. I know that I keep the numbers the same. I just switch the sign. That's all I do. So, positive 4, negative 5. Okay, this would have been in quadrant 2, 180 degrees. We put this in quadrant 4, and of course we know that's positive, negative. All right, good job.